what we're going to cover today is solving a system of linear equations. Now, as you know, a linear equation is an equation that when graphed is going to result in a line. A system of linear equations consists of two or more linear equations with the same variables, usually x and y. Now, we're going to do two different ways to solve this. The first will be by graphing, and then the second is going to be algebraically. The solution is an ordered pair that is the solution of each equation. If it's graphing, it is where the lines intersect. Now, the first way we're going to do this is by graphing. And the steps that we're going to follow are as follows. Okay, step one, we're going to graph each equation. We're going to graph them just like we've been doing. Graph each equation. Now, the only thing that's going to be a little different is that instead of just doing 2 points, we're going to plot a number of points because we want to figure out where they intersect, and we just don't know where that's going to be. So we're going to plot many points, especially for the first line, using the slope and y-intercept, just like we've done before. Okay. Step two is we want to identify the point of intersection. And you just want to tell me what it is. And label each line with its equation. And then we can check our answer by substituting the coordinates into each equation to see if true, to make sure that it's true. Okay, so let's go through a couple of examples. Example number one. I want to graph the lines y equals x minus 4 and y equals negative 4x plus 1 and figure out where they intersect. Okay, so to graph the line here, slope is 1 over 1, y-intercept is negative 4. So that one in blue I'm going to put here. And I go up 1, right 1. And as I said, I'm going to do this a number of times because I don't know where they're going to intersect. I can go down 1, left 1. I draw my line. And then I write y equals x minus 4 over it. The second line, slope is negative 4, or negative 4 over 1. Y-intercept is 1. If it has a negative slope, that means it's going to go up and down 4, or down 4, right and left 1. Now, you've got to be a little bit clever about this. I want to see where the red and the blue lines are going to intersect. So instead of going up, I'm going to go down 1, 2, 3, 4. If I go down 4, which is a negative, I got to go right 1. Well, I'm done right there because I found the point of intersection. I label this line. I write that my coordinate of intersection is 1, negative 3. Okay? And now to show you how you would check it, I put negative 3 in for y, 1 in for x into the first equation. It works. I put negative 3 in for y, 1 in for x in the second equation. And that works. And now I know for certain I got it correct. All right, let's go to the second one. All right, in green, my slope, again, is 1 over 1. My y-intercept is negative 3. in black, my slope is negative 1 over 5. My y-intercept is a positive 3. So I graph negative 3, that point, and I use my slope to get those other points. Looks very similar to the one we just did, different y-intercept. Then I do the next one. I start at 3. Now, again, since I want to hit the green line, I'm going to go down. So I go down 1, right 5, and bingo, I hit it. And my point of intersection is 5, 2. And if I plug 5 and 2 into each of these equations, it'll work. So 2 equals 5 minus 3. 2 equals negative 1 over 5 times 5 plus 3. Negative 1 over 5 times 5 is negative 1, and we see that it works. Okay? Now we're going to look at two special cases. Next one, I'm going to graph y equals 3x minus 2 and y equals 3x plus 3. So the first one I'll do in blue. My y-intercept is negative 2. The slope tells me to go up 3. 1, 2, 3 to the right 1. 1, 2, 3, right 1. So there's that line. And then the second line tells me to start at 3, go up 3, right 1. That's as far as I can go. Now, hopefully you're recognizing that these two lines will have no solution because they are parallel. So the conclusion is the lines are, that's one, sorry, looking are parallel since their slopes are equal and they have a different y-intercept. So what do we say for this? No solution. Parallel lines will never intersect. Okay? All right? So that's a next special case. Now let's do the next one. We have to solve for y. So I subtract x. This is negative y equals negative x plus 3. I multiply everything by negative 1, and I get y equals x minus 3. So that line would be like this. We actually did one of those before. Then the second one, I solve, subtract 2x, negative 2y equals negative 2x plus 6, divide everything by negative 2, and you get the same line. So when I graph it, it's going to go right on top. You don't have to do that because you would just have one line being drawn. So what is our conclusion there? Both equations are the same. So both equations are the same. So any ordered pair is a solution. Any ordered pair is a solution if it lies on either line. We don't say all real numbers because there are points that are out here, for example, that are not solutions. It's everything on one line is a solution for the other. Now, a second method to do this is algebraically, okay? And we can use two methods. One method is what's called substitution. The other method is elimination. But we're just going to deal with substitution, all right? So if you look at this, y equals x minus 4 and y equals negative 4x plus 1. Well, if y equals both of those statements, I can set each statement equal to each other and then solve. Negative 4 equals negative 5x plus 1. Negative 5 equals negative 5x. So x is 1. Now, the only thing is you've only told me x. You take one of these two equations to figure out y, because remember, your solution is an ordered pair, and you get your answer of 1, negative 3. Okay? Now, in this second example, I only have one of them as y equals. Now, you could do one of two things. You can convert this second one to y equals, but that may not be good because you may end up with some fractions. So another thing is what's to substitute means to take this and replace y with it. Okay? The idea is to get an equation with one variable. So I get 3x plus 4 times 2x plus 1 equals 26. I use my distributive property. And now I'm solving a straightforward linear equation. So x is 2. And then you just substitute 2 in for x. Choose the easier of the two to get y. So you get your answer of 2 comma 5. Okay? And that's the substitution method. All right, so to sum up, what we did today was to solve a system of linear equations, which means there are two separate equations with the same two variables, and we want to find out where they intersect or have the same ordered pair as the solution.